Hello everybody, in this lesson I will discuss 5 types of exponential equations, and somewhere in this video I will also explain this example. Exponential equations type 1. This is now where you find one term on each side. So the question is solve for x. When we look at 3 to the x is equal to 81, then you can see that there's one term on the left hand side and then there's one term on the right hand side. That's why I call it type 1. And then what you do is the 81 you will prime factorize, and 81 is 3 to the power of 4, and then you say bases are the same, both sides there's a 3 as a base, bases are the same, therefore we equate exponents, and then the answer x is equal to 4. In the next sum, the 8x to the power of 5 is equal to 4 to the power 2x plus 3. Your problem is the 8 and the 4. So what you do is you prime factorize. 8 is the same as 2 to the 3 raised to the x plus 5. And please note, can you see I wrote 8 and 2 to the 3 inside a bracket. And on the right hand side, 4 is 2 squared inside a bracket raised to the power 2x plus 3. And then in the next step, you're going to multiply in that 3 with the other exponents. So you end with 2 to the 3x plus 15. And on the right hand side, the 2 you will multiply with 2x and 3. Therefore, it's 2 to the 4x plus 6 on the right hand side. And now you can say bases are the same, therefore we equate exponents. And I end with 3x plus 15 is equal to 4x plus 6. And now I'm going to solve x. So what I did was 3x will go across and plus 6 will go to the left hand side. And then on the left hand side, 15 minus 6 is 9. And on the right hand side, 4x minus 3x is x. Therefore, the solution to your equation is x is equal to 9. The third example there, 5 to the 3x minus 1 is equal to 125. So your problem is 125. You prime factorize that, and it's 5 to the 3. And then bases are the same, therefore we equate exponents. 3x minus 1 is equal to 3. Now I'm going to solve x. So 1 will walk across and it becomes plus 1. And then 3x is equal to 4. And then solve x, divide by 3 both sides. And your answer, x is equal to 4 over 3. Type 2, where one side there's a normal fraction. So if you look at my sum, the first example, you will see here on the right hand side there's a fraction, 1 over 16. So the first thing you do is you write the 16th as 16 to the power of negative 1. And then you prime factorize 16, which is 2 to the 4. And please note, can you see I wrote it inside a bracket? And now in the next step, I'm going to multiply the 4 with the negative 1. So on the right, I end with 2 to the negative 4. And then bases are the same, therefore we can equate exponents. And x plus 3 is equal to negative 4. Solve x, negative 3 goes across, the plus 3 goes across and it becomes negative 3, and then x is negative 7. On the second example, again, you can recognize it as a type 2 since on one side there's a normal fraction, the 1 over 81. Again, you write 81 over 81 as 81 to the power of negative 1. And now you prime factorize 81, which is 3 to the 4. And again, please note, I wrote it inside a bracket. And now I'm going to multiply the two exponents. So on the right, I end with 3 to the negative 4. And then bases are the same, therefore equate exponents. So I end with x minus 2 is equal to negative 4, and then solve x. So the negative 2 will go across and becomes plus 2, and then x is equal to negative 4 plus 2, x is negative 2. Type 3. One side has a decimal fraction. So now you find on the right hand side there's 0,5. That's a decimal. So the first thing you do is you change the 0,5 into a proper fraction, which is 1 over 2. And then a half is the same as 2 to the negative 1. And then you back at type 1, where bases are the same. Therefore, we can equate exponents. So we find 2x minus 2 is negative 1. And now I'm going to solve x. So the negative 2 will walk across and it becomes plus 2. 2x is equal to negative 1 plus 2 is 1. And then to solve x, divide by 2, divide by 2, x is equal to a half. In the second example, it's a type 3, one side there's a decimal fraction. So on the right hand side, you find 0,125, which is an eighth. And then you're going to write the eighth as 8 to the power of negative 1. And then you're going to prime factorize 8 and write it as 2 to the 3. Inside a bracket, raised to the power of negative 1. And then now you're going to multiply the 3 with the negative 1. So you end with 2 to the x is equal to 2 to the negative 3. And then bases are the same. Therefore, we equate exponents, and the answer x is equal to negative 3. The next type 4, is where the coefficient is in front of the exponent. Now, if you look at the first example, suddenly there's a 5 in front of 4 to the x minus 2. So what you do is you're going to divide the 5 away, both sides. So on the left-hand side, when you divide with 5, it cancels with that 5. And then on the right-hand side, 80 divided by 5 is 16. And what you do next is you're going to take 16 and prime factorize it and write it as 4 squared. And then you say bases are the same, therefore we equate exponents. X minus 2 is equal to 2, and then the negative 2 goes across and it becomes plus 2, therefore x is equal to 4. On the second example, again, type 4, coefficient in front of the exponent. This is what you do, you divide the 5 away. What you do on the left, you do on the right. And then on the right, 45 divided by 5 is 9. And then you're going to prime factorize 9. And you write it as 3 squared. And then both sides you find the bases are the same. Therefore, we equate exponents. So 1 minus x is equal to 2. And now I'm going to solve x. So the x walks across and the 2 goes to that side. And we find 1 minus 2 is equal to x, and 1 minus 2 is negative 1 is equal to x. And then on the third example, you cannot say divide by 3 this side and divide by 3 that side. That's incorrect, since that 27 is raised to the power negative x. So what you do is you prime factorize. So 27 prime factorized is 3 to the power of negative 3x. And then you just wait with this 3, and 9 prime factorized is 3 squared. And then in the next step, you're going to multiply in that 2 into that exponent x minus 1. And then now in this step, we will look at this 3. On this 3, if there's no exponent written there, it implies there's an invisible 1. And then you find it's this 3 times the 3 to the power 2x minus 1. And that's law 1, right at the beginning. When you multiply, you add exponents. Therefore, you find 3 to the 2x minus 1. Since negative 2 plus 1 is negative 1. And now bases are the same, therefore we can equate exponents. And we find negative 3x is equal to 2x minus 1. And now I'm going to solve x. So 2 walks across, it becomes negative 2x. And then on the left, negative 3x, negative 2x is negative 5x is equal to negative 1. And then I divide away the negative 5 to solve x. What I do on the left, I do on the right. And then x is going to be plus a fifth. Type 5. Now there's the number 1 on the right-hand side. So if you look at my sum, there you can see there's the number 1. So there's a law that says anything to the 0 is 1. Now anything in this case will be 3, since what's on the left-hand side is a 3. So we change that 1 into 3 to the 0. And then bases are the same, therefore we equate exponents. X minus 1 is 0, and then when you solve x, the 1 will go across and x is equal to 1. And then the second example, you find 8 times 2 to the x plus 1 is equal to 8. Now you'll say, but it's type 5, where's the number 1? We're going to find it now. First of all, we will deal with this 8 in front. So we will divide by 8, they cancel. What you do on the left, you do on the right. And then suddenly you find 8 over 8 on the right hand side, which is 1. And now remember, back to the law, anything to the 0 is 1. So in this sum, on the left hand side, there's a 2. So we write that 1 on the right hand side as 2 to the 0. And then bases are the same, therefore we equate exponents. X plus 1 is 0. We solve x. This one will go across, and the answer x is equal to negative 1. In the next video, I will discuss difficult exponential equations. Click on the video in the left-hand corner to take you straight to the next video.